Just 2 minutes, okay? I started recording and we'll continue with the next thing now. Yeah, recording is started. I'll go for my screen sharing. Okay, okay, good morning. Okay, 11 people are there in the classroom. Yeah, one last question now. Is my screen visible? Anybody in the chat box? Just one last confirmation. Yes, sir. Thank you, Akshat. Okay, yeah, we'll continue now without wasting much of the time. Yeah. So, see, in the previous class, we were studying about process termination, right? So when you run a process, what happens when you want to terminate a process? So there are various ways of process termination. Like what I said is normal way and abnormal way. So when I say a normal termination, it is something like you return it. There are normal terminations are in three ways by using the system called return, exit, and underscore exit. So as I said, whenever you return a value from the main function, what does it do is it tells the operating system that whatever the statements you have written till now are executed successfully and now you can close the process. That is the use of system called return. Okay, then we said about the exit. Just a revision of that. So whenever you call exit in a C program, we have seen this, right? Like this, I'll just show you here again in the notepad. You wrote a main program. You said if I is something, sorry, I is less, sorry, I'll say I is less than 0, you wrote something, printf error, you had written something like exit 0 somewhere in the program like this, and this is a list of code. So whenever you write exit 0 in a program, we know now our C program terminates wherever it encounters exit 0. But when it encounters exit 0, what happens at that time is, see here. So whenever it encounters exit 0, the main function in main you'll write exit, so it comes to the exit function. Now what is the task of exit function? Before terminating, it does some cleanup processing. Cleanup processing, like it will release the resources, it will release the memory, and it will release the IO devices connected to that program. Whenever it encounters exit like this here, what it does is, before terminating, it does some sort of a cleanup processing, like it releases the resources which are allocated to the program, it releases the memory, and it also does the cleanup processing like release of IO devices and all. Then it writes to the kernel. That is where you get the prompt exit, right? But within that fraction amount of time, this is what the exit function does. And on similar lines, there we said underscore exit. Now, what is an underscore exit? Whenever an underscore exit function is called in a C program, like this, I'm talking, the underscore exit. Somebody is joining the classroom. Okay, maybe I don't. So whenever an underscore exit is called in the program, it also terminates your C program. But what it does here is, it will not do the cleanup processing. It will directly write to the kernel. Now it's a task of the kernel to release the resources. That is what the same example I gave the other day, right? See, for example, if there are 5-6 app open in your mobile phone, and you have some system update is done on your mobile phone. Now it tells you to restart your mobile phone. So what you do is, two ways are there. First one is, whichever apps you open, you close them, right? So what are you doing? You're releasing the memory from that app, which is nothing but an exit function. Please relate this, okay? See, you have a mobile phone. There are 5 apps already open in your mobile phone, and due to some system update, it tells you to restart your mobile phone. So what happens there is two ways. One way is you can just close the apps manually. You're doing it manually. That is releasing the memory, releasing the resources, releasing the processors, which is nothing but the exit function. Or if the apps are already open and still you restart the mobile phone, now who closes those apps? Your kernel closes those apps. So this is the difference between exit and underscore exit. Return is similar, like it releases everything and tells operating system that whatever the statements have been written by the user are executed successfully. That is what is told here. See, exit function. Exit and underscore exit will write to the kernel immediately, whereas exit performs cleanup processing. Now, what is the cleanup processing? Releasing of resources, releasing of memory, and releasing of I/O devices. That is what the function is. We have exit doesn't write anything, so it has a data type void. Exit int status. Now status are nothing but the numbers what we write. Exit 0, exit 1, exit 2, exit 3, and all, right? So same way we have for underscore exit also, right? So underscore exit also has the same thing. It has the status. We can pass any integer value there. Underscore exit 1, underscore exit 2, and so on. So what does it do there is, whenever an underscore exit is called in a program, it directly writes to the kernel without releasing the resources. Now it is a task of the kernel to release the resources. Again, the same example for this I'm telling, see, whenever it's your personal laptop, you close all the applications and then you shut down your system. But if it is a college lab PC and all, you never do that. You directly just shut down it, right? Close the button, power supply. So when you close the power supply, now it's a task of the OS to release all the resources. This is the difference between exit and underscore exit. And there is one more function known as at exit. Okay, please remember this. Now at exit is similar to exit function, but what it does is, it is a exit handler which calls the function in the reverse order of the registration, just like the vehicle gear, I mean to say. We have vehicles, right? We have gears for the vehicles, gear 1, 2, 3, and 4. So same way, at exit also terminates the program. Please remember this. At exit is a function which also terminates the program itself. But the only difference here is, at exit calls the functions in the reverse order of the registration. So whichever function, at exit function was registered last, will be executed first for me in the reverse order. First it goes to the main, and I'll show in the next program, okay? And then it reverses back and gives you the output. It is similar to exit only. Exit will return, do the cleanup processing, and write to the kernel. Underscore exit will directly write to the kernel. And at exit also exits. It is similar to exit only. But what it does, it exits in the reverse order of the registration. Now look at this example here, okay, students? Here, example of exit handler I need to say now. Okay, what is happening here is, here I'm calling a main function. A main function is called here. So I am calling an at exit function. Okay, so initially what happens, at exit is not equal to 0. This is never executed. Then it comes here, at exit function, it goes to this at exit function here, 1, first exit handler. But before going there, what it does is, just a minute. Okay, what it does is, this statement, when it is called, it goes to this function my exit to, where is my exit to return? Over here. So since nothing is passed, this is not executed. Again it comes to this, nothing is passed, this is not executed. So it comes here, printf main is done. So when you run this program, the very first thing is, this statement is executed. Main is done, which is shown in the outputs here. Main is done. So once this is done, then it executes the statements in the reverse order. Like now this statement is executed first. It comes here to this exit function. It goes to exit 1. What is the statement given here? First exit handler. So this statement is executed first. Then it goes to this statement and it executes the second statements. Only difference here is, it executes the statements in the reverse order of their existence. That is what's the difference between exit and at exit. Both does the same task. Okay, so this was about the normal termination. The next one is abnormal. See, normal you have to remember 3 things. In normal termination, the one is calling return, where a main function calls the return function and gives the value. Calling exit, what does exit do? Exit does cleanup processing. It cleanups the memory. Yes, it cleanups the IO devices, it cleanups the processes, and then writes to the kernel. Whereas underscore exit, it never does any cleanup processing. It directly writes to the kernel. Now these are the normal ways of termination of a process. Then you have, just a minute. Then you have abnormal termination. Now we all know what I mean by abnormal termination. See, what happens is when you're running any program and if your system goes in infinite loop and all, right? So directly you just alt control break, you press it, right? So what happens here is abnormal termination is one when you want to terminate a process when it is in a panic state. Now, what I mean by panic state is it is not doing anything. The expected output, what I'm expecting, is not there. So it does some other task only. So whenever a process is in a panic state, it is not giving the output as per my need. I want to abort the process. So abnormal termination is nothing but the calling system call abort. Now abort is a system call. Okay, I'll just show it here now. Abort is a system call, just like exit. So wherever you write abort, what it does is it does the same task as that of exit. But what is the importance of abort function call is, so whenever you want to terminate a process, you just use an abort function. Something like this. See, when you are installing something, if something goes wrong, your browser, you just shut down and restart it. Then what happens? A log file comes, right? It shows you in Windows also. If something is going wrong, it shows you program not responding. Wait for it to complete or close it. So you'll never wait it because it is still processing something. So what I do there is I close it. It is something like you're aborting the process. So the minute when you abort a process, the next time you start it, you get a log file saying that this was the reason for failure of this process. On similar lines, in Unix also, we have a function known as abort function. So whenever an abort is called, it terminates the process and in turn it creates a cease file. Now cease file is nothing but similar to a log file only. In Windows, what happens, right? We have a log file. Similarly, in Unix also we have a cease file, CESC file. So what is the task? What are the contents of that cease file is? It contains the data for the reason for the process to fail. Like it helps for you in debugging a process. It helps for you in a debugging a process. So this cease file is nothing but whenever any process is terminated or aborted, you always get a log file in Windows. Similarly, in Unix, you get a cease file. Cease file is nothing but telling the process like what went wrong that this process was aborted and how you can debug it. So this is abort system call is nothing but an abnormal termination. And there is second part of abnormal termination is calling signals. Now signals are nothing but the software interrupts. Signals are nothing but the software interrupts for a program. See, when you're running a system, automatically power supply goes off for me. Automatically internet stops for me. Now it's an interrupt, right? Because of that interrupt, we are not able to conduct my classes, right? So same way in Unix also, we have signals. Now signals are nothing but the software interrupts, the software disturbances, which will allow or which is used for abnormal termination of a process. That means when a process is going for an infinite loop, you can send a signal to stop the process. We have Alt Control Delete, right? When the process system is not responding to you, you press Alt Control and Delete from the keyboard. It's a signal. Alt Control and Delete is a signal which you are giving to the process for it to stop it. See, please remember Alt Control Delete. You do it, right? If something goes wrong in your system, we just press Alt Control and Delete. What is this Alt Control and Delete? A signal which you are giving to your operating system saying that system is not performing properly, you stop it. Same way in Unix also we have signals. Signals are nothing but the software interrupts, or they are nothing but the program written. And how can I do a software interrupt, or how can I terminate a program abnormally? By using the system called kill. Just like exit will close the process, kill will terminate the process. Okay, exit will close the process, kill will terminate the process. So these are the various ways of abnormal termination. Please remember in the exam they may usually ask you, explain the process of process termination. So there what the first and the foremost thing is, you should remember like I should explain this block diagram. And after that I should tell which are the different ways of process termination. There are two ways, sir. One is normal termination, another one is abnormal termination. So normal termination is a thing like calling the system called main, calling exit, calling underscore exit. An abort function, that is abnormal termination, is calling abort. What is abort? When a process is in panic state, we just call the system call abort. So whenever this abort system call is called, it generates a log file. We call here it as a sys file, which contains the data or the information about what went wrong. And the next one is terminated by signals, which are nothing but the software interrupt which are passed to the program. Okay. So this is all about process termination. The next one is command and argument. As we all know now, we have started studying command and arguments from first semester in our CCP. So every time whenever you have a command and argument, main by default it has two command and arguments. One is ARGC and other one is ARGV. ARGC is nothing but the number of command and arguments, whereas ARGV is nothing but the parameters passed to the command and argument. That is what we have studied. When a program is executed, process we can pass a command and argument. Command and argument has two arguments. Sorry, main has two command and arguments. One is ARGC, which tells me the number of command and arguments, and ARG is nothing but the parameters in the command line argument. And how can I get the command and arguments for normal program? Is like this. This is a sample program we have written. Okay, for I equal to 0, I less than ARGC. Now ARGC is nothing but the number of command line arguments. I keep on incrementing it. Print ARGV. ARGV is nothing but the parameter. So what is stored at first parameter? Arc of 1. First value, which is nothing but ARGV of I. Now if you look at this, I've just echoed a program. Okay, echo. First argument is ARGV1 test foo. So what happens is this becomes the 0th argument. This becomes the first argument. This becomes the second argument. This becomes the third argument. The only thing for you to remember here is main can be passed with two command line arguments, ARGC and ARGV. ARGC is nothing but the number of command line arguments, whereas ARGV is nothing but the pointer to the command line arguments. That is the parameters at each argument, first, second, and third. So this becomes your 0th argument. This becomes the first. This becomes the second. This becomes the third. The only thing to remember here is command line arguments are nothing but the arguments passed in the main at the runtime. Main has two command line arguments, ARGC and ARGV. Okay, please remember this. This is the only what we will study in the command line argument. Next is very interesting. Okay, students. Environment list. Okay. When I say environment list, please understand here now. So the minute I say, please tell me the configuration of your laptop. Please tell me the configuration of your laptop. If people you remember, you tell me, or else what you do, I'll just show you. Okay, what you do if I tell you to tell me the configuration of your system, the one and the best thing is I'll click on my computers, I'll right click, I'll say property. So when you do this, right click and properties, it will tell you, right, what is your computer name, what is your work group, see here, which version of Windows it is, what is the processor, it is Core 2 Duo, what's the processor, what's the RAM size, what type of operating system it is a 64-bit operating system, the name of the computer, the work group and all, right? So this is what you tell me when I ask you what's your system configuration, right? Same way in Unix also there are predefined variables for your system. There are predefined. We know now what is the home directory, what is path, what is shell, the user, the log name and all that. So this all home, path, shell, user, log name and all, there are n number of environment variables available in the system for you. So each program or each process can also be passed with a list of environment variables. So what are environment variables? Environment variables are the variables whose meaning is predefined to the kernel, and this can also be passed in a main program as an argument. This is very important. Okay, so we know only that main has two arguments, ARGC and ARGV, right? The similar lines, main can also be passed with one more argument. Main can also be passed with one more argument, and that is nothing but the environment list. So what is the environment list? Environment list is nothing but a list of environment variables. Which are the environment variables? Home, path, shell, user, log name. At the prompt you type, right? If I say home, it will tell me what's the home variable, the path home name. If I type path, it will show me that is PWD, present working directory you have used, right? Shell, which shell are you using? Bash shell, corn shell, C shell. Yes, same way, all this are nothing but the environment variables for you. Now, how can I get the environment variables? The environment variables can be get by passing one more argument to the main, the third argument, which is nothing but environment list, which is of type character. Two ways, either you can use this way or you can use this way. These are just the variation changing from OS to OS. Or there is one more way of getting it by a global variable environ. Now, sir, you have told. So how it works? So whenever you pass an argument, the pointer will just go to the environment list, which is predefined in your system. Please remember, this environment list is predefined in my system. So it just goes to the system, fetches the value and gives it to you. So these are the list of environment variables. So what is the environment list here now? Environment list is nothing but a list which contains an array of character pointers, and each pointer contains the address. And what is the last variable stored is a null variable. Now, how can I get all the environment variables for my system? Now, sir, you said only 4 variables: home, path, shell, user, and log name. But are there only this or many are there? So there are many environment variables available in the system. How can I get them? By different ways. So there are 3 ways of getting environment variables. Okay, in the exam usually they ask it, what is environment list, and explain the various ways of getting the environment list. So there are 3 ways. See, as I told you, how can I get it? By passing an additional variable parameter to the main. Now there are 3 ways. So one with env variable, that is what? The env variable. How can I get it? See here. The normal programming. So first is argc, number of command and arguments, argv, pointer to this command and argument, and third is the environment list. Optional it is, okay? Not every time I need to pass it. Whenever you are dealing with environment variables, you should always pass the third env. So what I'm doing is just declare a variable int j. For j equal to 0, env here, env of j not equal to null. Why not equal to null? Because now what I'm doing is now I'm referring to this environment list. All these are stored in this list where the last character is the null, which means the end of the list, which is the end of the list. So what I'm doing is here, right from the first location, keep on scanning till the last, till I find null. What you do is this. Okay. Till it points null, keep on incrementing it. So what it does here, printf comes %s. What does it do? It displays the environment variable available at the first location, 0th, which is nothing but here I say home now. Similarly, again goes up, j becomes 1, env of 1 is not equal to null, true, comes here, prints the second environment variable, prints the second, maybe path and all. So this will show in the program, okay? See here now. I've just already written the program here now. The same code what I said here. argc, argv, env. Now this is an additional variable which is passed when you want to get the environment variables of your system. Same thing. For j equal to 0, env of j not equal to null, j++, printf the value. So I'll run this program, okay? See, this code is visible here. I'll run this. So once I run, see, these are all the environment variables of your system. See here, host name, localhost, terminal is xterminal, shell is bash shell I'm working, user is root, library, Windows. See, so many are there. Desktop, console, pwd, that is the present working directory, the language and all. Here, so many are there. Which is the home directory? Home is the root directory. What is the log name? Is root, and so on. So all these environment variables are available in your system, ready-madely available for you. So this is one way of getting your environment variables. Yeah, clear with this, with the env variable. Second way is like by the variable environ. Now environ is nothing but a global variable which is declared by the system. Similar to this only, if you look at the program here, both resembles the same. Just only difference here is it is a global variable which is defined by the system for me. Just the different ways of you fetching the environment variables, okay? Same thing, ARGC, ARGV, ENV. What are you doing here is, again the same variable, you are declaring a global variable, environ. Now again it is of type char. Now why extern, sir? Now extern means it's an external variable which can have redundant values for it. See, on a single variable, if you're displaying n number of values, on a single variable, if you're displaying n number of values, I usually declare it a external variable and I just declare it, I don't define it. Here, it is just declared, not defined, okay? So same thing, what I did for env, the same is just replaced by environ variable. So again the same thing, from the first parameter till environ of j. Environ of j is nothing but again this list only, okay? As I said here, see, the address of the array of pointers is contained in the global variable environ. It's a predefined by the system. So what you do here is, rather than passing env as the parameter, I'm passing environ as the parameter here. So for j equal to 0, environ of j not equal to null, j plus plus, again the same thing. Fetch the first and display it in the same variable. See, I'm not changing the variable. So only it is declared as extern. Extern is nothing but a external variable visible throughout the program, and it is used only when you have redundant values for a variable. On the same variable, I'm declaring n number of values. Let's see how this works now. Okay, I'll just go here. I'll open the project. I'll just go here. Okay, environ, same thing. It is similar to env only, nothing difference at all. Same. env, just have passed environ as the variable. Let's see what will be the output of this. See, it also gives me the same output. What env gave. What env gave, same output. This only difference is a different ways I'm talking here. There are three ways. One is by env variable, getting all the environment list. Second is, see here, that is what we say, right? Tell me which all directories are available in your system. If I ask you, you may not remember all the directories, but if you just type ls, it will give you a list of all directories. Same way, you can get list of all environment variables in your system in three ways. One is by env variable, another one is by environ variable, okay? And the third way. Now, for example, I'm not interested in all these variables. You look at this output here. See here. Okay, I know now. I'm only concerned with which is the shell my system is using. Now it's a bash shell. Okay. Who is the user? Root is the user. Yeah. What is the present working directory? Environ, debug. Yeah. So I'm interested only few of the environment variables, not all. So in that case, when you are interested only in few environment variables, but not all, you can do that with the help of get env function. Now get env function, what it does it gets you the details of a specific environment variable. Please remember, this tool will display you all the environment variables. Env will display you all, environ will display you all, but whereas get env will get you the details of a specific environment variable which you specify. Look at the code here now. Get env, we pass a just which environment variable details you want to get it. Now same thing, character pointer, get env is a function which has only one parameter in it, home. So now I want the detail of home, so I'll write here home not equal to null, very true. So it prints home and displays which home directory it is. If this is not defined, it will give a message home not defined. Same thing, see here now. Again the same code, I've written the code already here for you, okay? I'll just say open, okay, get env. Just a minute. Loading. Just go here again. Open project. See here. And displaying with the home directory only. What I did in my code here is I've just specified the environment variable which I wanted. So here, if you want, you can specify path. It will display the path directory. It's a present working path. If you want which shell you are working, you have to specify shell. But to know which are the environment variables, first you should list them. I can get them with get env function, environment variable. Sorry, env variable or environment variable. Now, if I want only individual, I can get it with this, the third program. So please remember, there are three ways of listing a environment list. Environment list is nothing but the list of variables whose meaning is predefined to the system, and it is maintained in a form of a list where the last value in the list is a null variable, and this can be got by passing an additional variable to a main function, which is env. And three ways of getting it. One way is by accessing the value from env variable. Second way is by declaring a global variable environ. Why extension? Because extern, it gives the visibility of the variable for the entire program, and also it accepts redundant values for the variable. For this variable, we are having redundant values for each time. Getting it? And the third way is, if at all you want only of a specific variable. A specific variable can be got by this function get env. Get env will get me the details of the environment variables which is passed as an argument. Now, if I pass shell, it will display me shell. If I pass home, it will display me home. If I pass it PWD, it will display me the present working directory. Okay? Yeah. Again, coming back here. Is this clear? Is this a list of array? Yes or no? It's a list of array over there. Up to you, Abhishek. See, programming is your art. Abhishek Loni, right? Programming is your art. You, whatever you want, you do it as per your programming. You can dereference it or you can again re-reference it, up to you. Yeah. It's not that I have to do dereferencing pointer while printing pointer, up to you. However I want it, I code it. See, there is no fixed program for you to display it. Right? I can have n ways of displaying the program. It's up to you how well you use it. Okay, Abhishek? Okay. Next is very interesting. Okay, please pay attention. Okay. Okay. See this sample C program here now. You have a C program like I wrote something hash include stdio.h int a equal to 5 b int data 10 constant int I equal to 5 main. Yes. So we know now whenever a C program is executed, a memory is allocated to that. Right? Now assume that these are the memory blocks in the memory, and when you write a C program like this, the memory is allocated for this program a block somewhere in a block. Yeah. Now this is block number 1, block number 2, block number 3. I'll just edit this. I'll just say this is block number 1, this is block number 2, this is block number 3, this is block number 4, this is block number 5, and so on. Okay. So whenever you write a C program something like this, the entire program is allocated for one memory block. Okay. So that means it comes here and the memory is allocated for that. But now my next question is, when this entire program is allocated a memory block where it will be stored, again, how about the memory allocation for each statement? Now in each statement, it is not a bulk order. See, for example, I meant to say, okay, you have all your stuffs. Assume that these are all your stuffs and these are the wardrobes given to you. Assume that you have 5 or 6 brothers. Okay. So each brother has their own stuffs. So wardrobe 1 is given to you. Wardrobe 2 is to your brother. Wardrobe 3 to your sister. 4, 5, and so on. So my next question is whether you will dump everything in a single wardrobe, just like a database I told you. No. In the wardrobe also you have compartments. Yes, you have compartments where what data you will keep it. Very true. Yeah. Is this clear? And what I'm telling here is, assume that this to be a wardrobe, and these are all your stuffs. We don't dump everything in a wardrobe. In a wardrobe also we have various compartments given to me. Right? Some compartments I keep some stuff. One where books, one where shirts, trousers, and all. We do it. Same way for a C program also. Now this C program is allocated memory somewhere in the system by the kernel in some memory block. Assume that this entire program, the memory is allocated in this block number 3. But again in block number 3, this entire program is not dumped at one place. Again in block number 3, there are various compartments where each statement is stored in that compartment only. And that is nothing but memory layout of a C program. That is, we'll study now, taking this program as an example, in which memory segment this is stored in one block. Assume that this entire program is stored in block number 3. But again in block number 3, just like our wardrobes, I mean to say, we have compartments. So each statement should be saved in which compartment? How the memory is allocated for each statement. That is what we'll study in the next concept, is nothing but memory layout of a C program. Now look at this diagram here. So assume that block number 3 is this entire block. Now how a memory is allocated, again the same program I've kept as a reference here, okay? So it is memory is given from the lower address to higher address. So at the lower level there is a text segment. Above that there is a initialized segment. Above that there is an uninitialized segment. Above that there is a heap segment. Above that there is a stack segment, and above that there is a command and arguments. Okay, so this is how the entire C program is broken into pieces. So what is a text segment here now? Now text segment is a segment where memory is allocated for a single instance of a program, just like a compiler or editor. So we are running our C programs from a single compiler, right? So all those compilers, memory is allocated from the text segment. Now text segment is nothing but the lower address, okay? Here I've given here. Text segments are nothing but the machine instructions that are executed by the CPU. We'll go to and fro, okay? See here. Text segments are nothing but the machine instructions executed by the CPU, just like the compiler, editor, and all. So all those instructions, all this, when I'm talking about this ./a.out, cc, program name .c, all those machine level instructions, memory is allocated from the text segment. Okay. So here again they have given the machine instruction that CPU executes. Usually the text segment is a shareable, that it only keeps a single copy. That is what I said. There is only a single editor, compiler, shell, and so on. So only one shell will be there. For all those shell, memory will be allocated from the text segment. And what is initialized segment? We'll see here. I'll not go with the presentation here. See here. What is initialized segment? The variables which are initialized. The variables which are initialized, for them, memory is allocated from the initialized segment. Now, which are the variables initialized? See here, int a equal to 5. It is initialized, okay? And this is declared. Please remember that. This is initialized. This is just declared. So again, in initialize, there are two types. One is read-only initialized, and other one is read-write initialized. Now look at this program here. So only I gave the sample here, and I don't like to go with the text part here. So what is initialized segment? In a C program, whenever a variable is initialized, memory for that is allocated from the initialized segment. So which are the variables here now? Int a equal to 5. It is initialized. As I said, in initialized, again there are two types. One is read-only initialized. The other one is read-write initialized. So what is the read-only initialized? The variables which are constant or fixed. For them, memory is allocated from initialized read-only segment. Now, which is the constant variable here? Constant int I equal to 5. When I prefix constant, it means that value of this variable will never change. Right? So for this, the memory is allocated from initialized read-only segment. And there is one more variable, int a equal to 5. This is now initialized. So for this, memory is allocated from initialized segment, read-write segment. Getting this? What is initialized and initialized read-write? Then comes uninitialized segment. Now the variables which are just declared but not initialized in your program. Now which is a variable declared? This is the variable which is declared, int b. It is just declared but not initialized. See this, it is just declared but not initialized. So the variables which are just declared but not initialized, for them memory is allocated from uninitialized data segment. Clear this? Text segment contains all machine level instructions. Initialized segment contains the variables which are initialized. Again, initialized, there are two types. Initialized read only, which means that the variable which is initialized as constant, fixed, is initialized read only data. Again, in initialized, I'm having a equal to 5. So this is initialized read write. Yes, I've declared it a equal to 5. But down the lane in the program, again, this value can be changed. So it is for all the statements. This memory is allocated from initialized segment. Then comes uninitialized segment. Now what is uninitialized? Opposite of initialized. It is a segment in which the variables are just declared but not initialized. Now in my program it is nothing but it is b, int variables. It is just declared, no value is initialized to that. So for this, memory is allocated from uninitialized segment. Okay, this is clear. Now look at this variable, int x. Now int x is a variable which is declared in the main. Okay, so what happens for the value of x? You may keep on changing the value of x all time, right? X plus plus, x minus minus, x plus 5, x plus 10, and so on. So the variable who keeps on changing its values in the main, for all them the value is allocated from the stack segment. We know stack, first in, last out, right? So the variables which are just declared inside the main, for them memory is allocated from the stack segment. Why stack, sir? Because the value of this variable keeps on updating in the program. So for that, the memory is allocated from the stack segment. And look at this statement now. I hope you know what is a malloc. Malloc is nothing but dynamic allocation of memory at runtime, right? So whenever you have a systems like this or statements like this, what it means, at the runtime you allocate memory of 50 bytes to this pointer, right? So whenever you are allocating memory at the runtime in your C program, for all that the memory is allocated from the heap segment. Now what is a heap segment? Heap segment is nothing but a pool of memory, a bucket of memory. At runtime I may require memory for my C program. So what happens here is, for your C program, whenever the statements like this are there and you require memory at the runtime, all them the memory is allocated from the heap segment. And you have command and arguments. For them, the memory is allocated from the high address. See, we never thought like here, till now we were only knowing C program and I write it as a memory and we run it, but never thought how each statement memory is allocated. And they ask in the exam also. They may ask this, or they may give a program like this and ask you to write for each statement memory is allocated from which block. Okay, is this clear? I'll just come here. Got it, students? Memory layout of a C program. For each statement, how the memory is allocated. Clear with this? Anybody in the chat box for me? Clear with this? Yes. Okay. Yeah. Now you should give me the answers. Okay. I have already the answers. See, this is what I told now. Theoretical part again. Initialize data segment. Usually it is a data segment contains variables where variables are initialized. See, max count equal to 99. Now you are initializing this variable. When you are initializing, it comes from initialized data segment. Similarly, you have uninitialized data segment. This is block started by symbols. We call it as a BSS segment. So where you just declare, see here, sum equal to 1000, int b, float, temp and all. So when you write all the statements which are just declared, for the memory is given from the uninitialized data segment. Okay, we have stack segment where automatic variables are stored. That means the variables which are declared in main, please don't get confused. Okay, the variables which are declared inside main, only declared. Okay, for them the memory is allocated from the stack segment. from the heap is nothing but a dynamic memory allocation. So the systems like malloc, calloc, realloc, all that. Whenever you functions like that comes for them, the memory is allocated from the heap segment. Now look at this. Yeah, it's very clear now. Sir, you said int a equal to 5. Now it is above main, and it is declared. So it is allocated from which segment? Initialize segment, read write. Why read write, sir? Because the value of this 5 may change later also. Yeah. The next statement, int b, it is just declared above main. So for this, memory is allocated from uninitialized segment. As I said, uninitialized segments are nothing but the variables which are just declared. Int data equal to 10. So it is declared. So again, it is uninitialized segment. Constant int I equal to 5. What is this now? Initialized. Initialized with the prefix of constant. So it is initialized read segment. That means the value of I will never change down the lane. True? Then again main int x. As I said, just a variable which is declared in the main. It's nothing but a stack segment. So for this, it is given by stack. In pointer malloc heap segment. Clear with this? Usually asked for 10 marks in the exams. Okay. Explain the memory layout of a C program, a block diagram like this, and each statement explanation. For that, I have notes for me. My handwritten notes, I guess, are very helpful for you people now. I have notes, and again they may give something like this. Okay, a program may be given, and they may ask you to give each segment. So 5 marks for this, and 5 marks for this also might be. Okay, so we'll stop it for the day now. We'll have a break of 15 minutes, and we'll continue. Meanwhile, just answer this quiz for me now, which is nothing but your attendance course. Okay. Varun, yes, dynamic is allocated from the stack, but for stack is nothing but that is what I said, right? In the block, if you see stack and heap are in the same block. Stack and heap. If you look at this part here now, see here, stack and heap are in the same block. They share the same memory. It's the same stack only, stack segment only, but they share the same. So stack, it takes the memory for the variables which are declared in the main, and heap is the pool of memory. They're sharing the memory here. So for runtime, it comes from the same segment. So only see, if you look at this block here, no diversions or no distraction is given in this block. Everything is in the same block. They're sharing the memory. Look at the arrows also. It may expand, may compress. All are sharing the same memory. So that is what the stack segments are. Is this clear, everyone, students? I hope I cleared about environment list. Environment lists are nothing but the variables which are predefined in the systems. They are stored in a form of a list. I can get the list in 3 ways. One is by env variable, second one is environ variable, and third one is the function get env. Then we studied memory layout of a C program, how the memory is allocated. Normally we had a C program, but now we came to know now each statement how the memory is allocated. Yeah. We'll stop it for the time being now. Yeah, I'll join at 11 o'clock, okay? Yeah, I'll stop recording till then. We'll come back at 11 o'clock.